So, good morning, everyone, and welcome to this lecture. We are to lecture number 3, and we are doing projectile, and we are doing something which is known as the oblique projectile. I hope you now know what is an oblique projectile. Yes or no? Okay. So, when you throw any body not at 90 degrees, because at 90 degrees it just goes up and comes down, motion in 1D under gravity. If you throw it at any other angle, we call that projectile as your oblique projectile. Yes or no? We call that projectile as your oblique projectile. And as you can see, we had drawn this diagram of this projectile which was thrown at an angle theta. U was the initial velocity. Theta is known as the angle of projection. O is known as the point of projection. A is the highest point. B is the point where it lands back. The total horizontal distance that it travels in x-axis is known as the range or horizontal range. The height from, let me call this lowest point as C. The height from C to A is known as the maximum height from C to A. Then whatever time it takes, whatever time it remains in air is known as time of flight. Then there is time taken to go up, time taken to come down. What will be the relation between time taken to go up and time taken to come down? What will be the relation between time taken to go up and time taken to come down? Yes. Anyone?
2U/g, sir.
I'm asking you what is the relation between time taken to go up and time taken to come down? Will there be any relation between them? Time taken to go up and time taken to come down. Time taken to go up is the time taken from O to A. Time taken to come down is the time taken from A to B. Will there be any relation between them?
Time taken to go up is equal to time taken to go down, sir.
Time taken to go up will be time taken to come down. That is correct. Now let us write how are we going to solve this problem of projectile motion. We are going to write equations. Yes or no? What are the equations we are going to write? We are going to write equation on x-axis and we are going to write equation on y-axis, x-axis and y-axis. Now when we are writing equation on x-axis, we are only concerned about x-axis. So we draw the x-axis thing. If you want, you can draw the x-axis thing. This is the point O from where the ball was thrown, and this is the point B where this ball actually, or this body actually lands, and from O to B the total distance is R. Yes or no? Do we understand this, what I've drawn? This is only the x-axis that I've drawn. Now whenever we are doing any question of this type, you must take a sign convention. And what is the sign convention that we take? This direction is taken as positive, the opposite direction will be taken as negative. Now if I write the equation along x-axis, what are the things that you must remember along x-axis? Okay, the first thing is, what is the initial velocity along x-axis? Is there any velocity along x-axis? Is there any initial velocity along x-axis? Or what is the velocity along x-axis? No one knows? What is the initial velocity along x-axis?
U cos theta, sir.
Okay, you can call it as ux, and this ux will be equal to u cos theta. Okay, ux will be equal to u cos theta. What about acceleration along x? What is the acceleration along x-axis? What is the acceleration along x-axis? Is there any acceleration along x-axis? Yes or no? Is there any acceleration along x-axis? Difficult question. Is there any acceleration along x-axis? This is projectile motion. Told you everything that you need to know about projectile motion. Is there any acceleration along x-axis? Other answer is the answer is no. Yes. Tell me, beta.
0, sir.
Well done, 0, sir. So these are the two things that I know. Now I can write the equation along x-axis. The first equation will be final velocity at any point Vx will be equal to ux plus ax multiplied by time. We know that there is no acceleration, so we will understand that final velocity along x at any point will be same as initial velocity along x, and initial velocity along x is u cos theta. Do we understand this? Yes or no? That is the first equation that you can make. Remember, the equations are same. We're just using them along x and y. What is the second equation that you can make? Second equation that you can make is the displacement along, or the position along x-axis. Position along x-axis. If I just draw it here at any point, if it is here and this position is x, what is the value of x? How do I get the value of x? How do I get the value of x? Position or displacement along x-axis. How do I get it? No one knows? No one knows?
UT plus half AT square, sir.
Ux into t plus half ax into t square. I know that this ax is 0, so I will get this relation. Any position along x or displacement along x can be calculated by this form. So I can write it as u cos theta times t. So that becomes your displacement or position along x-axis. If you want, I can write the third equation as well. The third equation will be Vx square will be ux square plus 2 times acceleration along x multiplied by x. But you know that this is 0. So again, you end up with the same equation. So equation number 1 and equation number 3, they are exactly similar because Vx and ux are same because acceleration along x-axis is 0. Do we understand this? Now on similar lines, what I can do is I can make equation along y-axis. Now if I make equation along y-axis, I have to take a sign convention. So the sign convention that I'm going to take is very simple. Anything upwards is positive, so anything downward becomes negative. Now if you look at just the motion along y-axis, I can just draw it like this. Very simply, I can draw it like this. So the ball is here, it just goes up from, let us say, O to A, the highest point, and it just comes back from, this is H max, and this is this. Okay, what is the initial velocity that I throw it with up? That is my uy. How much is uy?
U sin theta, sir.
uy is, if I write it with sign convention, it will be plus u sine theta. This should be plus u cos theta. Okay, what is the acceleration along y-axis? Is there any acceleration along y-axis? Is there any acceleration along y-axis? Yes or no? Is the body accelerating along y-axis? Yes or no? Yes, beta?
Minus J.
Minus g. Why it is minus g? Why minus? Because acceleration is downwards. G in the downward direction. So it is minus g. Minus g. Now if you want, I can write the equations number 1, 2, and 3. Equation number 1. What will equation number 1 be? Final velocity along y will be equal to uy plus ay into t. Ay is minus g. So I can write it as minus g into t. I can put the value of uy. So it will become plus u sine theta minus g into t. That will be your final velocity at any point along y direction. Do we understand this? Yes or no? What would be the second equation? Displacement along y. Y will be equal to uy into t plus half ay into t square. Acceleration is minus g, so it becomes minus g into t square. Yes or no? I can put the value of uy, so it will become plus u sine theta into t minus half g t square. That becomes your second equation. If you want, from this equation, you can find out the value of the displacement along y-axis. You can also write the third equation. And how does the third equation look like? Vy square will be equal to uy square plus, okay, let me write the first equation, plus 2 times acceleration into y, acceleration of y multiplied by y. I can put the values of uy. Uy is plus u sine theta, ay is minus g, and I will end up with the formula for velocity along y-axis. Do we understand this? Yes or no? Okay. So that's it. Basically, this motion can be broken up into two, one along horizontal and one along vertical. If you see, horizontal motion is very simple. It is without acceleration. The vertical motion is simply motion under gravity that we have already done. It is one-dimensional motion along gravity, up and down, up and down. So both the motions we are done. If we put them together, we will get the total motion of the body. Do we understand this? Yes or no? So now I'll give you 2 minutes to note this down. Please let me know once you are done.
Done, sir.
Everyone in the other class also done?
Sir.
Done, beta?
Yes, sir.
Okay. Now we have done this. Now if we put both these motions together, we will get the motion of this body in totality. So you have to put all these motions together. Now let me draw that motion again with a new fresh diagram. So this is my y-axis, this is my x-axis. I throw the ball like this. U is the velocity of projection and it goes like this. And theta is the angle of projection. It reaches a maximum point A. This is O, this is B, and let us say this is C. Now you take any random point. Let us say this is the point. Let me call this point as D. Now at this point D, what will be the direction of velocity? Now, I told you that many times. At this point D, how will the body be moving? How will the body move? In which direction does the body move? Can anyone tell me? At this point D, how should the body be moving? Anyone?
Tangential, sir.
Tangential. Remember, I told you the direction of instantaneous velocity is always tangential. So the velocity will be like this v. Now this velocity can be broken up into two components. One will be vx and one would be vy. Do we understand this? What is the value of this vx? What will be the value of this vx? Just tell me.
U cos theta.
This vx and this ux are all same, and that will be equal to u cos theta because velocity along y-axis does not along x-axis does not change. Do we understand this? Now, what about this velocity? The velocity along y-axis vy. What about this velocity vy?
U side theta minus GT.
Well done. So if I have to write this velocity as a vector, I can simply write this velocity v as vx I hat plus vy j hat. Do we understand this? Yes or no? So basically, I can write it like this. This velocity v will be equal to u cos theta I plus u sin theta minus gt times j. Do you understand this? Yes or no? If someone asks you,
Yes, sir.
what is the magnitude of this velocity? If someone asks you, what is the magnitude of this velocity at any point? What is the magnitude of this velocity at any point? So how will you find out the magnitude of this velocity? Magnitude of
Under
this.
root U cos theta plus U sin theta minus GT.
Say again.
U cos theta whole square plus U sin theta
U
whole
cos
square root of.
theta whole square plus u sin theta minus gt whole square. Now, if you do the whole square, you will get one term of u square cos square and u square sin square that will become equal to 1. So this will be the final result that you will get u square plus g square t square minus 2 u g t sin theta, because one term One term will come from here, that will be u square cos square theta. One term will come from here, u square sine square theta. U square taken common, cos square plus sine square becomes 1. So this is the final result that you get. Do we understand this, or this has gone above our head saying bye bye? Okay. Now this will make, oops, wrong color. This will this velocity will make some angle, let us say phi, some angle phi with the x-axis. This velocity at any point will make some angle phi with the x-axis. How can you find out the value of this phi? How can you find out the value of this phi? They can ask you.
Tan data.
This is phi and this is theta. Are they same? Are they looking same? How will you find out the value of this phi? Tan of this phi will be equal to Vy divided by Vx. So that will be equal to u sine theta minus gt divided by u cos theta. Do we understand this, how this is done? Yes or no? It is that simple. Now, the other thing that you must understand that this point has an x coordinate. This is your x. And this point has a y coordinate. This is your y. Yes or no? Okay. What is the value of this x? What is this x equal to? If I assume that I have taken tick, 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 t seconds to go from here to here, from here to here, I have taken t seconds. What is the value of x?
U cos theta t, sir.
X will be equal to u cos theta into t. Yes or no? And y will be equal to? Y will be equal to? X will be u cos theta into t. What about y? Y will be equal to? Y. This y.
U sin theta t, sir.
This y. This x is correct. What about this y?
U sin theta t, sir.
What about this y? Yes, what about this y?
U sin theta t minus half gt square.
U sin theta into t minus half gt square. Do we understand this? Do not forget these things, because these things are going to matter a lot, because you might not get a straightforward question in this. You might get a question where they ask you all these things that I'm telling you. So it is u sin theta into t minus half gt square. Do we understand this? From there, I can write, again, don't get confused. I can write the displacement vector of this particle, how much it has displaced. And the displacement vector of this particle will be xi plus yj. Do we understand this? Along x, it has moved x. Along y, it has moved y. Now, how do I draw the displacement vector? I will draw it like this, tongue, 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 tongue. And now the diagram looks very bad, so I will try to do it in a different diagram, smaller one, so that you are able to understand it. So I'll do it here so that we understand how this displacement vector looks like. This is my x and y. This is my projectile. The point D is here. So what do? I draw a straight line now. This curve is also looking like straight, so that might create confusion, but I will draw a straight line. This is your displacement vector. Do we understand this? This is your displacement vector. It has got two components. Wrong color. It has got two components. One is this component, which is x. One is this component, which is y. Do we understand this? And then you can put the values and you can get your answer. If someone asks you what is the magnitude of displacement or what is the distance of this particle from the origin, you can find it out by using root over x square plus root over y square. Do you understand what we have achieved here? Yes or no? Okay. Now, I will not write the value of x and y because it will just become too much. So I'll just leave it here. If someone asks you, find out the angle. Now, remember, theta is the angle that velocity makes with x-axis, initial velocity. Phi is the angle that the velocity at point B or D makes with the x-axis. Now, this angle, will it be same as theta or phi? This angle, which angle? This angle, let me call this as xi. Will this angle xi? Right now we have three angles. One is phi here, tung 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 tung. One is theta here, tung 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 tung. And one is this xi here. Are all the three angles same? Are all the three angles same? The first one is theta, angle of projection. The second one is phi, which is the angle that a velocity at any point makes with the x-axis. The third angle is the angle that a displacement vector makes with the x-axis. Are all the three angles same?
No,
Yes,
sir.
sir. Then what is the value of this tan of xi? The angle that the displacement vector makes with the x-axis. How much is that angle?
Y by X.
Well done. It is y. We already know the value of y and divided by x, and we are done. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, bye bye? Chalo, I'll give you a minute to note this down, then I'll give you a question.
Sir, please scroll up, sir.
We have talked about initial velocity, we have talked about velocity at any given point, and we have talked about the displacement vector of that given point. I hope we understand this. Please let me know once you are done.
Sir, scroll down.
Done, sir.
Everyone has done this?
Yes, sir.
Okay, let us then solve this question. Question number 1. You understand the concept? This should be easy. A body starts from origin with an acceleration of 6 meter per square. Starts, so that means initially it is at rest. Starts from origin with an acceleration of 6 meter per second square along x-axis and 8 meter per second square along y-axis. Its distance from the origin after 4 seconds is. How will you find out the distance from the origin after 4 seconds? If you understand what we have done just now, you should be able to do this. I'll give you 2 minutes to do this. Do you want a hint? This is the hint on your screens now. Back to the question. Yes, shall I do it? There is a slight difference between this question and projectile motion. The first question that I'm going to ask, is this projectile motion? Yes or no?
Yes, sir.
Okay. Then find out the distance from the origin after 4 seconds. What type of motion is this? Projectile motion? Motion in 1D, motion in 2D. What type of motion is this?
Motion in 2D, sir.
No. It's not motion in 2D. This is simple motion in 1 dimension. Strange? Anyways, a particle starts from origin. So its initial velocity is 0. So I can write u along x, initial velocity along x is 0. Uy is also 0. Both are 0. Acceleration along x is given as 6 plus 6. Acceleration along y is given as plus 8. I have to find out the distance from the origin. If I just draw the diagram, simple diagram, this is x, this is y. At time t is equal to 0, the particle is here. After some time, it is somewhere here. I have to find out its distance from the origin. How will I find out its distance from the origin? I will have to find out the length of this line. Yes or no? How will I find out the length of this line? I will find out this x. I will find out this y. So this will become root over x square plus y square. Is it difficult to understand? So I have to find out the value of x and y. How do I find the value of x and y? I make the equation along x-axis. X is equal to ux into t plus half ax into t square. Remember, this is not a projectile motion. Ux is 0 and ax is 6. So I get the value of x. X is equal to half into 6 into t square is 16. How much I get? 48. Then I find the value of y. Y is equal to uy into t plus half ay into t square. Here also uy is 0. Cut it out. So y becomes half. Acceleration along y is 8 into t square is 16. That becomes 64. So what is my distance from the origin? If I call this as r, what is the value of r? What is the value of r?
80.
80. Anyone got it on its own, or
Yes,
everyone
sir.
was? You got it yourself?
Sir.
Well done. See, so it was a simple question. The thing that I wrote here was the displacement of the particle from the origin. This is actually the distance of the particle from the origin in a straight line. In a straight line, it is the distance of the particle from the origin. Yes or no? Now coming to the case of understanding what type of motion is this. Someone said it is projectile motion. Absolutely wrong. Someone said that this is motion in 2D. Absolutely wrong. This is motion in a straight line. Now, how do I understand that this is a motion in a straight line? A particle is at rest, not going anywhere. Now, I give it an acceleration. Like this. Like this. Particle is at rest here. I give it an acceleration. This acceleration has an x component. This acceleration has a y component. The total acceleration is like this. Where will the particle move? This is not physics. This is simple common sense. Where does the particle move? This is my particle. This. I give it an acceleration like this. Oi! How does it move? It will keep on moving in the same straight line. So remember, whenever a particle starts from rest and it is free to move, it will always move in the direction of acceleration, right? Yes or no? Because it will move in the direction of force unless and until something is there. Now, if I keep it on ground, then the case is different. Because if I apply a force like this, it cannot move like this. Then it will move along the ground, but that is a different case. If it is free to move, and if I apply a force like this, it will go like this. It will keep on moving in the same direction. Do we understand this? So this is the case of motion in a straight line. Do we understand this? Yes or no? Okay. So if any question comes where they ask you the distance from the origin, basically find out x coordinate, find out y coordinate, and then find out root over x square plus y square. I had to tell you this, and that was the reason why this question was done. Every question has its own reason why it is done. Let us bring the next one up. Everyone is ready? Yes or no? All these questions are being done so that you get confident. And when these questions, and for some of these questions would come in your exam. When I say exam, I mean JEE. Done? Let's move on to the next one. And here comes question number 2. And let's see who does this one. Once you do this one, I can understand that whatever I have told you, there are two things that I have told you. One is about the displacement and the other one is about the velocity. A body is thrown at an angle of 30 degrees to the horizontal with a velocity of 30 meters per second. After 1 second, what will be the velocity? The answer has to be in meter per second. You have 2 minutes to do this. Yes, my dear friends, boys and girls and boys. G has to be taken as 10. Huh? What is the answer? Let's see who gives me the answer first. Race again time. Time again race. No. Race again time. Girls versus boys. Boys versus girls. Each one against everyone. Everyone against each one. You against 15. 18. No. Around 10 lakhs. You again 10 lakh. 8 to 10 lakh students sit for JEE every year. Yes. No one got the answer. Everything is given in the question. To find the velocity after 1 second, my dear friends. Huh? So long, so long. Shall I do it? It seems that I would have to give you a hint. And the hint is right now on your screens. You must understand that once we do something once, and remember JEE is only cleared in the classroom, it is never cleared in the examination hall. If we do the hard work here, then only we will reap the rewards and the results in your final exam. You are not going to solve any single question in the final exam. You're only going to solve questions here, and then you are going to replicate it. Same questions are going to come and you're going to replicate it. Yes, what is the answer? Well, 1 more minute. I will wait. It is 9:19. I will wait till 9:20. Everything is given that is needed. Angle 30 degrees. Velocity 30. 1 second. G10. So how do you do it? 9:20 is already there on the clock and your time is over. How do you do it? First of all, you need to find the magnitude of velocity at any point. So you should find out Vx, square it. You need to find out Vy and square it. You know how to find Vx, you know how to find Vy, or if you can remember the formula that we had derived or devised, it is U square plus G square T square minus 2 UTG sine.
Sir, option A.
Sir, option A, it has taken a bit longer to get you the answer, but I'm happy that at the end of the day, you got the answer A. Well done. That is the answer. Vx is Ux, U cos theta. Vy is U sine theta minus Gt. So you can find Ux, find Uy, square them, add them, and find the root, or straight away put it in this formula. Whatever way you do it, you will land up with 10 root 7. Everyone got this? Well, if you are finding it difficult to calculate it, I would suggest that you do some practice where you can get used to this. Everyone understand this? Can I move ahead? Everyone confident? And try to see what you were thinking, where you were correct and where you were wrong. And this is one thing that I would have given you as note, but I'll give you as a note after this question so that you remember this question and this note. This was previous question from one of the JEE. It was known as the IITree. It has come many times in JEE as well. In a projectile motion, what is the velocity at the maximum height? Don't have to write the question, you just have to tell me the answer. At the highest point, what is the velocity, my dear friends? And you will not get an entire lifetime to give me the answer. You give me the answer now. What is the velocity?
Answer C.
Answer C, u sine theta by 2. That is wrong. What? How did you
U
get?
cos theta by 2, sir.
Okay, so I've got both the answers. By 2 is looking like in fashion these days. And by 2 looks good, but that whatever looks good in physics may not be correct. Whatever does not look so fancy is the answer, and the answer is B, u cos theta. Why it is B, u cos theta? At the highest point, something becomes zero. What becomes zero? What becomes zero at the highest point?
Velocity, sir.
What becomes zero at the highest point, my dear friends? I have told you that. Not directly, but indirectly. Look at this diagram, gentlemen and girls and ladies. This gentleman was the horizontal motion. No, no, no. This gentleman was the vertical motion. No, no, no. What happens at the highest point, my dear friend? We have discussed this at least 1500 times. At highest point, what will happen? I did not write it knowingly. At the highest point, what will happen? At point A, what will happen? Huh?
Velocity will be 0.
I again ask my question. What happens at point A? You're giving me half of the answer. Half of the answer is dangerous. What happens at point A? The time has run out, and the answer is Vy component becomes 0. And there is a hell lot of a difference between you saying velocity becoming 0 and velocity ka y component becoming 0. Because bacha, if velocity becomes 0, it will not go anywhere, it will just fall down. Then and there itself. This does not happen. It does not fall down, it keeps on going aage. Why it keeps on going aage? Because the vertical velocity is 0, but horizontal is not 0. Horizontal velocity at this point is, wow, how much? How much is the horizontal velocity at this point? My dear friends, nothing in the universe changes horizontal velocity because we are studying projectile motion in this universe where f is equal to ma is valid. Only 4% of this universe we can see. 96% is dark matter. We don't see it. But still, horizontal velocity remains constant. U cos theta. Vertical component is 0, horizontal component is u cos theta. Now I come back to the question, and now the answer is pretty straightforward. At highest point, your vertical component of velocity becomes 0. Your horizontal component of velocity is always u cos theta, otherwise it will fall down. Therefore, the net velocity is Vy square plus Vx square ka root, and you will get the final velocity at point A is same as the horizontal component. That is what you must remember and understand. We understand this, or this is gone above or saying bye bye? Bye bye, I'm going. Chata. If velocity becomes zero at any point, it will not go any further, it will just fall there. Does not fall at the highest point. Keeps on going. Thoda aur aage. So, I hope, 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 I hope. What do I hope? Okay. Chalo, do we understand this? Huh? Ah. Let's see if you can do this one. This is a question that I will devise. A particle is thrown with velocity. Why is my voice sounding like a bell in a temple? Dung, 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 echoing everywhere. No one is in the temple and I am the only one ringing the bell. A particle is thrown with velocity u at angle theta. So u is the initial velocity and theta is the angle of position. After some time, we don't know the time. After some time, the velocity becomes v. Find the angle of v with x-axis. So after some time, this velocity, it was initially u at an angle theta. Now it become v. You have to find out what angle. 9:29 is already on clock. You only have 1 minute. I'll give this as homework probably. If you can't do it in 1 minute. A particle is thrown with an initial velocity u and an angle theta. After some time, and the good thing is we don't know at that time, the velocity becomes v. Find the angle of v with this x-axis. Remember, the question which has the least amount of information is the simplest question. Because you don't only have to deal with one or two things. A question which has a lot of data is obviously simple because everything is given, you just need to calculate. In short, the moral of the story is every question is what? Simple. A question which only has two things given is simple because only two things are given. You only have to think about those two things. A question which has got a lot of things given, time is given, velocity is given, g is given, this is given, that is given, is simple because everything is given. Moral of the story, every question is simple. So this is the question for the homework. Let's see who can get me the answer. Remember, answer is only an answer when it is given in terms of things that are known. There are two things that are known here. What are the two things that are known here? Three things that are known here. One is u, one is theta, third one is v, and g is already every time known. So your answer should come in terms of u, theta, v, and if required, g. So best of luck with this question, and I will discuss this question in the next class. If you have any doubts, you can always come up to me. I've sent you a sheet as well. Did you get that sheet? Probably today you will get it. I have sent you a sheet, practice sheet for projectile motion, and I can assure you that if you can do even 60% of the questions from that sheet, one of those questions will be there in your exam. I mean, when I say exam, I mean the final exam. If you can do 100%, well, you are probably done with projectile motion. Okay, so with that, whatever it is, we'll meet In the next class, tomorrow is Sunday, so you have enough time to solve that sheet. Not everything you will be able to solve, but the good part about that sheet is everything is given in small sections. So you can just read what is at the top of that section. If you think that we have covered this in the class, you can do those questions. Then you move on to the next section. Then you again read what is the heading of that section. So it becomes simpler for you to solve it. Okay, so this has been a very extensive assignment that I've sent you, with everything written in small headings. So even projectile motion will be under, I think, 8 or 10 headings. Very small thing. Every small thing, every small point is there as a heading. Read that heading. If you have done that point, then solve that portion. Otherwise, move forward to the next one. Do we understand this? There are two
Yes,
sections.
sir.
One is for JEE Mains, one is for JEE Advanced. So the advanced section will have advanced written there. Okay, so solve it. Just need to concentrate on that. You don't need to do anything else. Okay, take care. Have a nice day. Bye.
Thank you, sir.